Identify the core concept. The root mean square, RMS, speed, URMS, of gas molecules is a measure of the average speed of particles in a gas. According to the kinetic molecular theory, it is defined by the formula URMS equals square root of 3RT over m. Analyze the variables. From the formula, it is clear that molecular speed depends on two factors. Temperature, T speed, is directly proportional to the square root of the absolute temperature. Higher temperatures result in higher speeds. Molar mass, m speed, is inversely proportional to the square root of the molar mass. Heavier molecules move more slowly than lighter ones at the same temperature. Eliminate non-factors. Note that pressure, P, does not appear in the URMS formula. While pressure affects the frequency of collisions, it does not change the average speed of the individual molecules at a given temperature. Compare temperatures. The options provide two temperatures, 200 degrees Celsius, A, B, C, D, and 300 degrees Celsius, E. To find the lowest speed, we should first look at the lower temperature, 200 degrees Celsius. Compare molar masses at 200 degrees Celsius. Using the provided periodic table, calculate the approximate molar masses for the gases at this temperature. H2, approximately 2 grams per mole O2, approximately 32 grams per mole SO2, approximately 64 grams per mole, sulfur approximately 32 plus 2 oxygens approximately 32, and H3, approximately 17 grams per mole. Conclusion. At the same temperature, 200 degrees Celsius, SO2 is the heaviest molecule. Because it has the largest molar mass and is at the lowest temperature provided for that mass, it will have the lowest root mean square speed, option C. The correct answer is option C. SO2 molecules at 20 atmospheres and 200 degrees Celsius.